I'm going to be introducing derivatives today. In my previous video, I discussed the slope of a curve at a point. And the slope of a curve at a point is m, which is a slope, is equal to limit as h approaches 0, f of x plus h minus f of x over h. And this is the slope of a curve at a point. Now, a derivative of a function with respect to x is f prime with respect to x. So let's just write that out in terms of notation. Derivative of a function f is f prime, that's the f prime notation, with respect to x. So this is actually very similar to the formula we stated above here, and it's just f prime is equal to limit as h approaches 0, f of x plus h minus f of x over h. However, in this formula, we'll be finding, instead of just at a point, this is to find the slope at a point like a comma f of a. And here, we will find the slope, the average rate of change of a function, of a whole function. So let's do an example. Let's do an example. Okay, so example. So the example we'll take today is f of x is equal to square root of x. So what is f prime? So our formula above states that f prime is equal to limit as h approaches 0, f of x plus h minus f of x over h. So f prime, limit h approaches 0, now let's replace these things. So f of x plus h is square root of x plus h minus square root of x over h, and this is a limit h approaches 0. And now, if we go on with this, it will be, to solve this actually we'll have to take the inverse and multiply the top and bottom. So we'll multiply this by the square root of x plus h plus square root of x over square root of x plus h plus square root of x. So this is really 1, but when we multiply it, it'll make it easier to solve. So limit as h approaches 0, x plus h minus x over h square root of x plus h plus square root of x. When this x and that x cancels out, and we get limit h approaches 0, h over h, and since h is, well, let's just do it this way now, x plus h plus square root of x. And since h is approaching 0, we can still cancel this out, and since h approaches 0, this will be 0, so this is just square root of x plus square root of x. So it's just 1 over 2 square root of x is equal to f prime. So the answer to the problem up here, f prime is equal to 1 over 2 square root of x. However, f prime of x might fail to exist. And this topic is differentiability. Topic of differentiability. And so for a function to be differentiable, it must be continuous. So the first thing, it must be continuous. And continuous, for a function to be continuous, has to fill 3 things, which are the limit as x approaches c of f of x exists. The second thing it has to be is that f of c actually exists itself. And the third thing is that the limit x approaches c f of x equals to f of c. So these 3 things must occur for a function to be continuous. The next parts of differentiability is that there must be no corners. So no corners, which are this. So we can't have any corners. No cusps. So we can't have any of these things, which go like, actually, like that. That would be a cusp over there. And we can have no vertical tangent. So whenever you see a definition of what's differentiable, it always says a non-vertical tangent line. So you cannot have anything that looks like or resembles this, or anything with a vertical tangent like that over there. It is not differentiable at that point. So that's about it, and that's a quick introduction to derivatives.